Good morning, colleagues, and thank you for your time. Today I present my research design in my doctoral dissertation examining ethical AI integration in the intelligence community, specifically with a focus on false positive reduction. I will walk through the design logically. Research question, theoretical objectives, variables, hypotheses, conceptualization, and measurements, to include data and methods, strengths and weaknesses, with solutions, and practical and policy implications. Moving into our research question and our theoretical significance, the central research question is, how does implementation of AI ethics algorithm combined with intelligence analysis training and data quality variations influence the rate of false positives in the intelligence community threat assessments? Within our lives, AI affects pretty much every aspect, specifically in the intelligence community, with its automative improvements and helping to quickly overcome problem sets and help support decision making. What I hope to find is new groundbreaking material or additions to what has already been built upon from the giants of the past. Building on the authors that I found, I felt will help enhance and discover additional findings that could tell us which way the false positive rate may go. It can be good, it could be bad, but nevertheless, we want to find out evidence to help implement this through with independent variables to help see if it does change my dependent variable in this situation. Even outside the military and the intelligence community, in all aspects of our lives, it doesn't matter what profession, career, or atmosphere, we see how automation can play a role in either helping things to be more efficient, or in some cases, like in the military with targeting, we see how AI can possibly help alter and possibly give us good results or bad results, falsely identifying a target that was a friendly opposed to being an enemy. So what we want to focus on here is, how do we get to the more good? How do we get to the more positive information and data that's coming out of AI to help affect decision making so we can make better decisions and help solve those problems? Theoretically, this contributes to AI governance and intelligence studies by testing how ethical embodies algorithms enhance descriptive and causal inference, according to KKV. Some of the many authors we'll be building upon is Chen in 2021 and then Zibak of 2022. In essence, they study the domains of cybersecurity and the medical diagnosis that doctors were using within AI. Hopefully, some of this can be transferable to the AI community, in addition to other work to help find commonality with the concepts of reducing false positives, in their case with cybersecurity and the medical. Challenges within the IC community will be the classifications. It's difficult a little bit to study this in the academic world, but not impossible, considering the security classifications within the IC community, considering you have unclassified, secret, and then top secret information. So we got to be very careful on the information that's being looked at. But there are areas where we can help build upon what's been done already through previous authors. The dependent variable is the rate of false positives in threat assessments. In other words, when information is spit out for decision makers from AI, and it could be the user combination, how accurate was that information? Was it positive? Was it negative? Or was it neutral? We want to measure the rate in which the information we wanted to get correct is increased, whereas the information that was wrong is decreased. So we look specifically at the false positive rate which tells us whether that information that came from AI was correct, or even in some cases with individuals integrating with that, or was it wrong? So that's the rate we want to look at with the dependent variable. And we want to implement and see how we can affect this through the independent variables and see how that's going to change the rate, whether the rate's going to go up or down. But nevertheless, we want to measure that rate and see how what we can do through our independent variables, how that rate's going to change, whether it be good or bad. And we don't know what we're going to find, but that's what we're doing the research for. With measurement validity, we'll focus and use the work of Adcock and Collier 2001, using percentage calculations from alerts and content versus ethical benchmark evidence. With the independent variables, they are external. We want to take a look at two specific areas. And number one, the AI algorithms. How were they coded? We know humans code the programs for AIs to help make those decisions. We want to look at the inner workings and the structure and how that worked. One key aspect of coding is, does it have a Christian worldview theme to it? Does it have a different theme to it? All those little things and how you code and the person involved and the guidelines they follow affect the AI algorithm. The second one is the specific training for intelligence analysts. Analysts come in all sizes, shapes, and forms, from different backgrounds and everywhere. But what we want to specifically look at is what kind of training do they get and how that affects the dependent variable. So in other words, based on the training of that analyst, whether it's 8 hours a week or 8 hours a year annually, how does that affect or not affect the dependent variable? So those are the two key things we want to look at. Number one, again, being the AI algorithm that was programmed, how that would affects the false positive rate. And then number two, the training involved, or to include ethics training with the intelligent analysis that works towards the change or not change in that dependent variable rate. Looking at our hypothesis in a situation, we have three. Hypothesis number one, will stronger ethical AI coding programming reduce false positive rates? Will that have play a role and help reducing the bias that possibly AI can produce? Hypothesis number two, will increasing the training positively affect this rate? Will it have no effect? Will it have a good effect? Will it have a bad effect? Does increasing this intelligent analyst training help that out? And finally, hypothesis number three is looking specifically, does better data into the system reduce the rate? Will that affect it? Or does it not matter? Does AI help eliminate some of the bad data? So we could take a look and see what we find. We don't know where we're going to go, but we want to see what it does find. When discussing method and data, we're going to use a mixed method of quantitative and qualitative approach. For quantitative, we want to use regression for causal effects, whereas with qualitative, we want to use a structural case comparison. And again, this is following the principles of Lepard in 1971 for depth. As mentioned before, data will be challenging considering the classifications of the situation within the intelligence community. Nevertheless, data will include declassified intelligence community reports, Freedom of Information Act, simulated databases, and analyst surveys, panel, pure post-intervention and control with settings, and random based selection avoids biases. Now, considering the strengths, we got to look at King, Cohen, and Verba. We are, going with an external independent variable, and also we're doing no selection of the DV. Also, using precise concepts helps us avoid the pitfall, which Sartori always emphasized about. We're focused specifically within the intelligence community and specifically the AI With the weaknesses, we got to look to what was mentioned before with the security classification. The intelligence community renownedly is mostly a secured environment. So based on that, it'll be difficult at times to really get good data and what's being used in a secured environment. We have to focus on the unsecured environment, considering the information that's available. Now, considering solutions. Depending on the findings we have within this research, ultimately the goal is to help reduce the false positive rate. If we find evidence that is instrumental in doing that, we can build upon that to see how that could be applied within the intelligence community to make our algorithms and human oversight more accurate. The key here we want to emphasize is the human oversight. We want to avoid a situation where we just have the AI system itself making the decisions. We want to have that human element involved to look at it and say, wait a minute, this is good information, this is bad information. Nevertheless, we don't like the route it's going, its decision. That target is not 100% identified, so we have to stop a strike, possibly avoiding the effect of hurting an innocent individual in this case here. So with the solutions, we want to see how we can make the algorithm process synchronized with human oversight to help reduce that false positive rate, which we're all aiming for, in this case here within the intelligence community. Relating it to public policy. Now, based on our findings, it could help implement and help guide public policy. Again, AI is only as good as it's being programmed and utilized by the users. So with the public policy aspect, we want to hopefully see this can go in a route where it can help guide AI policies. And we can translate it almost to the industrial age back in the early 1900s, where industry giants were taking advantage of cheap labor and exploiting, humans, child labor laws. We want to make sure that hopefully this policy can guide AI in such a way that we don't fall into a trap like we did during the industrial age when we had child labor laws, unprotected unions, and areas where they were unsafe for human conditions. So again, we want to do the same thing today, moving forward into the AI revolutionary, or what we call the fourth revolutionary stage. We want to make sure it's ethically implemented in such a way where it's not violating human privacy, where it's not wrongly identifying targets. We want to use it in such a way where it has that Christian theme of positively affecting the society and making it better. So wrapping this up, again, this is some interesting work that I found it interesting because I'm in the line of business of using the very AI algorithms and machinery that helps enhance the intelligence community, but it also affects all other areas. It could be medical, it could be industrial, it can be law enforcement, anywhere. We want to hopefully get to a point where, yes, AI is beneficial. It does, for efficiency-wise and production-wise, it helps eliminate a lot of mistakes and help us be more productive. But along that route, we want to make sure we're operating in an ethical environment and an ethical approach. So AI is not biased. It's not violating privacies. It's not giving us wrong information. So again, hopefully I can build upon the giants in the industry and hopefully build upon what they've found so far in their evidence and make AI more productive and yet more ethical for the future.